the remainder and factor theorems. Now, the remainder theorem is pretty simple. At this point, for the most part, you've proven that you're good at synthetic division. And so when we talk about the remainder theorem, we're talking about something that's called synthetic substitution, which is a little bit different than synthetic division. Okay? But the process, the algorithm that we use to do synthetic division is exactly the same for synthetic substitution. Now, we'll just give you a heads up right now when we get into these problems. There will be some problems on your test next week that will require you to do synthetic substitution. Okay? And so here's what it is. We can use synthetic division, that process, to evaluate a function. And on your quiz, and in 5.3, we had to find things like f of 7 or p of -4 or those kinds of things. When we say evaluate a function, that's what I'm talking about, the stuff that we did in 5.3. Okay? The trick is, when we use synthetic substitution, is when we go through the whole process, what ends up happening is the remainder is that actual value. And I'll show you how to set it up. And I'll show you the slight difference between synthetic substitution and synthetic division. And then we'll be able to find the value of a given function. So here's the kind of problem we're talking about, okay? So in 5.3, in order to find what f of 4 was, we would plug 4 in for x, and we'd go to the calculator, which most of you were pretty good at. Little exception here or there. And then we'd figure out what f of 4 was, okay? So today, I'm going to show you a different way of doing that. I think you're going to find this way maybe even cooler. Cooler, yeah. Now, so here's how we would have done it, right? This is what we would have done. You can write this down or not. You can skip this in your notes if you want to, too. It's up to you. But we can just plug 4 in, simplify that. This all is called evaluation. Okay, this is evaluating. So when you get to a test and it says evaluate the function of f of 4, this is what you would do. Okay, my answer is 662. And we had problems like this on your quiz yesterday. Again, you don't need to write all this down. You know how to do this. Okay? What I want to show you is that if we use synthetic substitution, we can come up with 662. I think, I'm going to be honest, especially when we have negatives, some of you guys have trouble with all the different powers and putting it in your calculator the right way and simplifying. A bunch of you, this was a 4 in this problem. Some of you wrote the wrong power down yesterday on the quiz. So, yeah, I'm sticking with my thing. I think you're going to think synthetic substitution might be a little cooler. So here we go. This is what it's going to look like. Synthetic substitution will give us the same answer. That's the key. But in a very different way. I'm pretty sure on your test you still have to do both ways. I could be wrong about that. This might not be on the test. Synthetic substitution will absolutely 100% be on the test. I will tell you that, okay? So here's what this looks like, okay? And so on the next page, on the next slide here, I'm going to show you the setup. The setup is very much like synthetic division, okay? How many terms should I have here? 5. Which one is missing? Yeah, the x squared is missing. So that part is the same as synthetic division. Normally what we would do is we would take the number and we'd change its sign from the binomial that we would get. For synthetic substitution, you do not change the sign. It was right here. This was the answer. Okay, so when we go through and do synthetic substitution, Okay? That's the biggest difference. That this number here will always be the exact same sign as whatever the number is that we're trying to evaluate. That's the part that is different from synthetic division. The adding zeros in, same. But the number that goes on the outside, that's the change. So go ahead and finish this. When you go ahead and complete the calculation, this is what you should have ended up with. Okay? Now, notice that I did not put it as a polynomial or anything like that. But we already knew the answer to this particular problem, right? We had it on the previous screen. What was it? That's why it's called the remainder theorem. Where we normally have the remainder, that is the same as figuring out what f of 4 is. Okay? Now, again, I think some of you will have a better time at it this way than you would by actually plugging it in to the polynomial. That's why I said I think some of you will think it's cooler. Okay? Because then you don't have to raise stuff to powers. You don't have to multiply. You don't have to worry about plus and minus signs being wrong because some of you had that problem on the quiz yesterday. Okay? And so this is what synthetic substitution allows us to do. And that's why it's called the remainder theorem. Because in the spot that normally would be the remainder is the actual evaluation. Okay? F of 4 equals 662. Obviously, we could plug the 4 in, figure it out like we did in 5.3, and figure out what f of 4 is. But this is another way to do it. And again, this will be on your test, 100%. Okay? I can't remember. That's all there is to the remainder theorem. We have not talked about the factor theorem yet, which we need to talk about next. Don't worry about it. We'll get to the end when we get to the end. What else you got to do today? Okay, we will. All right, let's get to the, actually, I want you to try one. Here's one for you to practice. Yes. Practice this one, please. I don't know, when I got this example, for whatever reason, they had it written as g of x, and we want to find f of negative 1. So this is actually f of x. This is what your setup should have been. Okay, we're missing the x to the 4th, and we're missing the x term. Okay? So we needed to make sure of that. We put those zeros in. Now, the other thing, again, the change between synthetic division and synthetic substitution, this number is always exactly the same. Only in synthetic division, when we have a binomial, do we change the sign. Okay, so then you just go from there, of course, and you get the remainder is negative 6. Therefore, f of negative 1 is negative 6. That's the answer. That's how you should express it at the end. Okay? So in your homework tonight, when you're working on this, and you're asked to evaluate using synthetic substitution, this is what you would do.
Wait, I have a question.
Yes.
Questions like this, is it gonna have two variables, or like 2f equals whatever? Like f equals negative 2 and f equals 5?
You could have two. There's potential that one of them, they would ask you to find two different values. It's possible.
Two different boxes?
Yeah, then you have to have two different things if that happens.
Okay.
All right, let's move on to factor theorem. Okay, so the next part of this, it's related to remainders, and we've talked about what factors are before, but we're going to go into it a little more in-depthly today. All right. If a binomial, now we're going back to binomials. If a binomial goes into another polynomial evenly, meaning the remainder is 0, we've talked about this before, then that binomial is a factor of the polynomial. Okay? So anytime you did synthetic or long division and the remainder ended up being 0, meaning that binomial went into the larger polynomial evenly, that means that binomial was a factor. And one of the things that we're going to do in this section and later on in 5.7 is we're going to find all the factors of a polynomial. Some of that is going to involve just regular factoring the way we did in chapter 4. Some of it is going to require us to do some new types of factoring, which I'll teach you on our next block day in 5.5. Okay, because we're going to learn some new methods of factoring. But what we're going to be doing here is they're going to tell us, here is one factor. This is one factor of a polynomial. And it's going to say, find the remaining factors. So here's how that's going to work. Here's what the problem is going to look like. Okay. So the first thing it says is show that x minus 2 is a factor of x to the third minus 7x squared plus 4x plus 12. So that's the first part. We're going to demonstrate that that's a factor. And then the second part says find the remaining factors. All right. So there's two things. There's two things that we're doing in this problem. We've talked about this all year about making sure you're following and reading directions. There's two things in this problem that you have to do. All right. So in order for x minus 2 to be a factor of that larger polynomial, you have to divide them and show that the remainder is 0. Okay? So that's the first step. And now in this case, we're actually doing synthetic division. Or you could do long division if you wanted. Some of you, as I was going through and grading the quizzes yesterday, some of you seem to like long division better than synthetic division, and that's totally fine. Notice it doesn't ask for you to do the division any specific way. Overall, a majority of you seem to prefer synthetic division, and so I'm going to use synthetic division. The key thing here is, when I set this up, this is where we got to remember opposite sign. Okay, so this is positive 2, even though this is x minus 2. So when we do synthetic division, we have to do the opposite sign because of that binomial. Synthetic substitution is a little bit different where that sign stays the same. So go ahead and do this. What should happen is the remainder ends up being 0. That's what should happen. So we go through this, and you should get 0 for your remainder. Okay. What this demonstrates is that x minus 2 is a factor. Okay, and here's an explanation of that. So x minus 2 is a factor of the larger polynomial because the remainder equals 0. So what I've done is I did this part right there. That part is now done. And I gave a little bit of an explanation demonstrating why that is true. So we're left with the second part, find the remaining factors. Again, keep this in mind. In order to be a factor of a polynomial, when you divide them, it's going to divide evenly. And when dividing evenly means there will be a remainder of 0. Okay. Now, it asks us to find the remaining factors of the polynomial. I'm going to do that on the next slide. Okay. But here's what I have so far. Okay. What I have so far is x minus 2 times x squared minus 5x minus 6. So my remaining factors are going to be built into this polynomial, this new polynomial. And so I'm going to have to figure out what those are.
So where do we get that from?
Right here. X squared minus 5x minus 6. Okay. Now on the next slide, we're gonna talk about the remaining factors. Okay. And so what we need to do is actually factor that trinomial. So go ahead and do that. Factor that trinomial back in like how we did in chapter 4. This is something I said to you way back in chapter 4. Factoring needs to be something that you're really good at as we move on to higher level math. And the fact that I watched some of you multiply this out still are having trouble understanding the difference between factoring and multiplying. Remember, factoring is undoing FOIL. And so What I'm looking for here, since this is a leading one, I'm looking for factors of -6, things that multiply together give me -6, that add up to -5. What two numbers multiply to -6 and add up to -5? -6 and +1. Okay? So when we say factor, that's what we mean. And those of you, if you're struggling with factoring still, you need to go back and review. It's just going to keep coming up. You're expected to know how to do that. Okay? Now, the question said, what are the remaining factors? It didn't say all the factors. Okay, what I've underlined there are the remaining factors because they gave us the first factor. It says, what are the remaining factors? So those are those other two, right? And so my final answer would be something like this for part 2. The remaining factors are x minus 6 and x plus 1. Now, if the problem said list all the factors, I'd have the x minus 2 there too. But it didn't. It asked for the remaining factors outside of the x minus 2. So be very careful with what the directions say and make sure that you are answering those properly. Okay?